So we're looking at what joint variation. Okay.
Yes, sir.
So as usual, we've been discussing about what variation for the past 3 days now. So today we're going to be looking at what joint what variation. Okay. So we'll see how joint variation, how this problem can be solved. Are we following now?
Yes, sir.
So as we've done so far, we did the direct variation, the inverse variation, and right now we are going to be looking at what joint what variation. Are we following now?
Yes, sir.
Then joint variation here simply means that yes, two variables will what worked upon. That is to say, they will give us maybe they'll say, okay, if x varies as this one and inversely as what? Are we getting that? X is varying a particular something directly and inversely. Are we following now? That means two things are involved now. Before it was direct, that means A to equals to B, right? But in this case now, we're doing it like in this way. A varies directly as something and inversely as what? Another thing. Are we following now? Are we together? That's what we shall be looking at. Are we together? Let's see how this problem can be what solved. Are you following now? Let's pick an example and see how it goes. Example on example 0. Are we following now? Example what? 0. This thing simply means what? The formula on how to what approach such what situation. Are we there now? Let's assume we have one x vary as what? Z as y inversely as what? Z. Are we following now?
Yes.
This is just an example of what how a joint variation looks like. Are we there now?
Yes.
This one is x vary directly as what? Y and inversely as what? Z. There are 3 things here now. 1, 2, 3, right? They are what they are called what joint partnership. Are we following now? Just as in business, we have what joint partnership, right? So that's just how this looks like. And this one, this all over what the other member. But in our inverse, it was 1 all over what a member, right?
Yes.
Are you following now?
Yes.
In inverse, what 1 all over, right? X is inversely, x varies inversely, right? 1 all over inverse, not a particular something, but an inverse of another thing. Are you there now? But this one now is a direct stuff and also an what an inverse form. Are you following now?
Yes.
That's just how it looks like on the joint variation. Are you following now? Let's now pick what a normal what example, then we'll solve. Thank you. Now example 1. If y varies directly as x and inversely as inversely with y. Is it y? Sorry. Inversely with z square. Inversely as z square, comma y is equals to 18 when x equals to 6 and z equals to 2. Calculate the value of z when x is equals to 720 and y equals to 15. Are you following now? This is just an example of what we shall be looking at. Are you following? Now see what we have on the board. They said what example if y varies directly as x and inversely as what z square, y is equal to 18 when this one is equal to and z is equal to what 2. Calculate the value of what z when x equals to this and y equals to this. And also I said the connection. Let's put the connection, Abby. Are we? Okay, number 2. Number 2. Find the connection. Find the connection. Find the equation. Sorry. Find the equation. Find the equation. Find the equation which connects x, y, and z. Full stop. Are we there now?
Yes.
So I'm looking at what this money of x, y, and z, right?
Yes.
They said if x varies, right?
If y varies.
Is it y?
Yes.
If y varies directly as what? X, right?
Yes.
As x, and inversely as what? Z.
Z square.
Right?
Z square.
Z square. You say calculate what? They say calculate what?
They say when
Calculates y. Check your
calculate the value of z when x
equals
equals
to
to
720.
20.
Thank you very much. Now let's carry on this way, okay? For then, let us bring our constant, right? Okay. We have the y. Now that we're using the equals to put our k, right? Kx all over what? Z square, right? Are we together now? Okay. Now let's start imputing what? Our values, right? What's y?
15.
15, right? What's
Why
x?
is it 10?
Why is
720.
Right?
So we're not sorry for the constant.
Let's
Okay.
bring down everything first now.
Why is it 10?
Y
18.
15.
Yes.
What's x?
6.
6.
Yes.
And what's z?
2.
2, right? Are you sure it's 2?
Yes.
Okay. You sure it's 2?
Yes.
Yes.
Okay. Now, let's now substitute them into what?
The form.
The formula, right?
Yes.
They say y is what? 18 equals to k. What's x? X is 6, right?
Yes.
6k, right? Are you following now?
Yeah.
Because 6 is not supposed to be at the front, rather it must be at the what?
Back.
At the back, right? All over 2, right?
Yes. 2
2
square.
square, right?
Yes.
Because your z here is square, right? Calculate now. Now 18 now. We now have 18 equals to what? 6k over what? 4,
4.
right? Because 2 times 2 is what?
4.
Right? We now have to cross multiply, right?
Yes.
Cross multiply this now. 4 times this gives us what? 36, 72, right?
Yes.
This multiply now we have what? 6k equals to what? 72, right?
Divide both sides.
Divide by 6. Divide by 6. 6 cancel 6, right?
Yes.
We have k left equals to what? This and this. This was what? This was 1, 4. No, give us 1, 2, 12. Am I right? Am I right? How do you divide it?
Yes. 12.
12, right? Okay, that's beautiful. So this is what we have. Okay? We have our k to be what? 12 now. Oh, do you get that now?
Yes.
Let's now move toward the next level. Now let's now see how to approach what we have been asked to calculate. The first thing they say what? Calculate what z when y is equal to this and x equals to what? This. But thank God that we've gotten what our concept to what? 12 now. Let's now digress a little bit. First of all, you bring down your formula, right? Y equals to what? K x what? Y z what? Square, right?
Yes.
Now what's y in the question there?
Y is 15.
15. Y is what? 15 equals to
17.
12, right? 12 times what? What's x?
720.
720 all over. Was that given? No. Z square, right?
Yes.
You have to multiply, right? This time is right and this time is right.
Yes.
This time is what? Let's first of all multiply that one first. 15, right? Equals to what?
8,640.
8,600 what?
40.
40, right?
Yes.
All over what? Z square, right? This time you have to cross multiply, right?
Yes.
You have to cross multiply, right? We now have Z square, please. This 15 times this gives us what? 15 what?
Square.
Z
15
square.
Z square, right?
Yes.
Equals to what? This time this, the same thing, 8, 6, 4 0, right?
Yes.
We have
Divide
by
by
15, right?
yes.
Are we there?
Yes.
15, right? Are we there?
Yes.
This cancels, right?
Yes.
Z squared is equals to
576.
make sure 5, yes, 5,
576.
7, 6. I would have done this, no problem. Now
Square.
we have to square this now. I have to put square root here now, right?
Yes.
And put what is square root here now. So we can cancel this, right?
Yes.
This cancels, right? Are we?
Yes.
So now Z is equal to what? This
24.
So,
24.
24. Are you sure? I lie.
Is it not the square root?
This, I'm not sure that this one has square root too. I'm not too sure.
Yes. See it here.
24.
24.
Jesus. This is what? 24. Right?
Yes.
So our answer here is what? 24. Are we getting that now?
Yes.
So now the formula, now let's just do the formula here now, okay?
Yes.
The number two now. What's the connection now? We have formula to be what? Y, right? Equals to what? K x over what? Z squared, right? We now have it as what? Y must come back. What's K here? K is 12, right?
Yeah.
K is what? 12 x over what? Z squared. That's number 2.
Is that all?
That's all. Any question on that? Any question on that?
So when they say find the
Any question on that?
when they say find the equation that connects the x, y,
The x, yes.
It's
What you
just-
just do is this: you bring down the what k value, which is the
that
constant value.
okay.
Then where the constant value is on the formula, just put it there and bring down everything that has been there. Don't change anything.
I know.
That's the connection. Okay.
Yes.
Do you get that now?
Mhm.
Thank you. Please, you have to subscribe to my channel.
That's all.
Okay.